Well, what do we reckon this is? How about a Uniden 300 base station with a load of extra holes in the top, which the customer is saying, wonder why. I didn't like the look of this mains lead. So we've got, that looks like the sheath's missing there. So if that's a join or whatever, we may well be replacing that mains lead. I hope the customer likes grey ones because that's what we have. I really ought to check the mains plug first. People who aren't in the UK may have, yeah, I see. I haven't got the right screwdriver here, but I'll just roughly check there, something like tight. We've got the wrong fuse in the plug. It's a 13 amp fuse in the plug, and that's no earthly good. It needs to be a 3 amp fuse in the plug, and we'll address that later on when we look at the this situation with the mains lead. So I put that together for now. My bench is on a contactor and an earth leakage circuit breaker, and the whole thing's fused at 3 amps anyway, so we can plug that in, and I'm not actually worried at this stage. So that does need addressing. I can't do anything about, well, I'm not going to do anything about the holes in the case. Perhaps I would, if it was mine, put some car body filler in, but there you are. I recall these are M4 screws. We have black replacements, but we don't have silver replacements. So we'll try not to lose those, which will be incredible. Actually, before we take the lid off, I may as well take the bottom off, because we've got to go underneath. We've got to go underneath because I will be replacing the capacitors in the power supply, whether it needs them or not, and I will be replacing the two 220 microfarad capacitors on the main chassis, because if they haven't been replaced already, they will fail any time. One of those problems is you end up with the power to the synthesizer being shorted out, and you lose your channel display, and that's one or the other or both of the 220 microfarad capacitors. There's a 470 microfarad capacitor on the main board in, I think it's in the audio department without looking, and that's now at the end of its life after 38 years. That's another one we automatically change. So we're going to be automatically changing 3 capacitors on the main board and all the capacitors on the power supply. Now we don't see many Uniden radios or audio line, and I may not have the power supply capacitors in stock. They may have to be ordered. We don't take jobs off the bench. This might be on the bench for several days, which then stops us doing other CB radio work. Bearing in mind I can only spend about 90 days, I can only spend about 90 minutes a day on CB radio because of the main business in church organ restoration. Nothing to do with electronics. So that doesn't look awful. So we'll carry on taking the lid off. Now this has lost its front channel knob. He's hoping, he thinks I'm going to have some replacement. I'm going to have nothing like. When we buy scrap chassis in, that's exactly what they are. When I buy something off eBay as a scrap chassis, that's what you end up with. No case, no knobs, if it had a meter, no meter, all those kind of things. Usually no output transistors, have usually been robbed. That's how I buy scrap chassis. So we don't end up buying anything scrap with knobs. So we'll see if we can find something, but it won't match. Nearly dropped that screw. That would have been the first one lost. There's one thing, it's never been fagged. That means cigarettes in other languages. So what we got there? We've got 2200 at 35 volts, which we should have in stock. We've got a 220 microfarad capacitor of exactly the same type there that fails here and here. So this is a definite candidate that's not had any of those capacitors changed. So in his notes, please find my Uniden 300, which I purchased on eBay in 2013. For some reason it's got holes in the case, channel selector knobs missing. Otherwise it's unmessed with inside. Please fit a replacement. You've got something suitable. I now haven't. Included is a Shaman's mic that came with it, which is absolutely fine. It's a standard replacement coffin mic. Receiver sounds scratchy. No transmitted audio. S-meter has stuck. Now, you see, he wouldn't mind a knob, so that's possibly not going to happen. He's not that happy, I don't think, with the mic, but that will be absolutely fine. Transmitted audio will be a fault, and the S-meter is stuck. It's a bit like taking your car for service and say, well, the speedometer's stuck. You know, is the garage going to take your speedometer apart and fix it? And is there anything I could do? So you know what we're going to do? I'm going to start by doing something which is I'm going to regret, and that is taking apart his meter, because I think we're going to end up fixing it worse. And the thing is, I can't magic another one from somewhere. Unless we pinch one off one of those President KP77 radios that I hate. But then he'd have to pay for the radio we've pinched it off, wouldn't he? And I might hate them, but I still believe them to be worth 45 quid. Okay, so that's got the clip out. We're going to do one of those KP77s in the not too distant future. We're going to start by putting the whole radio minus the meter and speaker through the dishwasher. Because unlike this lovely immaculate set, that is awful. Now, let's remove the lamp. Or not. Looks like the meter comes out through the front. So I'm already starting to regret it. Can I pull any of the knobs off this radio? No, I can't. And I do have exceptionally strong fingers. You know, that's incredible, isn't it? It's got a knob missing and I can't even pull the others off. Right, well, we don't want to mar the finish. There's several ways to do this. One of them means going across to our church organ workshop and getting a ball of string So I'll tell you what, we'll borrow the soldering iron sponge and see whether we can remove this with a bit of force. Don't do this if you haven't got a steady hand. Because the last thing we want to do is to mar the finish in any way. That one has come straight off. I'll just widen this camera just in case you can't see what we're doing. So using the soldering iron sponge as a lever, getting the screwdriver, and that's the second one we managed to get off. I'll tell you what, we'll put it that way on. Luckily there is a gap, so it's not like I'm having to put. The other thing is to tie string round and round and round and round, and eventually it will pull that knob off. Right, well that's managed that without marring the finish. Now then, what about that headphone socket? Does that stay put? Have I missed a screw? Yes, I've missed a screw. I don't think I've ever taken one of these off before. I've only ever seen 2 other Unidens in 38 years, and probably 3 or 4 audio lines. So that leaves that behind. Whilst I'm at it, I may as well. It's a very clean radio, but I may as well just clean that front. So be careful with that. Going to have to unsolder the meter. So black goes to positive and grey goes to negative. How bizarre is that? So there's adhesive tape which kind of holds this meter together. Obviously they're a cheap product. We have Scotch tape on a roll, on a reel, on a dispenser to replace that. And then we've got the bottom one as well. It's where we change the glasses. So I'm looking, have we got clearance between there and the needle? And yes, we have. So what's causing it to have stuck? Is there a foreign body? With my ceramic tool, so it's not magnetic, what happens if I try and touch the meter? I'm going to back off the bearing at the back. And it's now moved to its natural position. So I'm going to very lightly blow on it. Just going to slacken that off an absolute merest fraction further. Now there's no fee for this. I'm not entering into a contract. I'm just doing this to help him. We do not repair meters. So we'll put that tape back over there. And I'll go and get the reel of Scotch tape. And it now looks like it's going to be okay. So I'll pause the video while I'll go and get the reel of Scotch tape. Right, I'll remember to go and put that back in the office. And we'll now solder this back together. I'm going to tin the connections. And we know that black went to positive, which is so bizarre. I'll see whether it's possible to start refitting that bracket. So that is screwed back in. It's interesting to see on the front panel, if I can just tilt this in such a way that the wiring reaches. If I can tilt it in such a way that the wiring reaches. No, I can't. Can I do... What can I do? I can't. I'll move the whole radio. Look how the front plastic moulding has got extra knob positions for different models, and it's just the escutcheon, there's a good word for you, the actual black metal bit that is different for this model. So I'm just going to, I'll go and get the foam cleanser, and we'll just pop some foam cleanser on that. No idea where to put it. I'll just go and get a piece of kitchen roll. Never over tighten these. There's so many fronts on mobiles and base stations that are cracked. They just need to be snug. I'll put the knobs back on, so I'll turn them all to the minimum position. I'll just move the camera so you can see what I'm doing, because I've got it resting on my knee, and I'm wearing shorts this morning, so I won't be this afternoon when I'm going to go and tune a church organ. So we don't really want to show me bare legs, do we? So these are all at minimum. So the idea is to get the little knob ident thing to the bottom left corner. So let's say that's 7 o'clock position. So we get those all the same. That's the standard minimum position. Doesn't want to go on that one. There we are. So now we will want mic gain and RF gain to full, and they can stay put. So there we are, we're back together. So whilst I've got it on my knee, we'll switch it on. Oh, it was on 19. Well, at least we're getting a bit of deflection on that meter, so there we are. But I can't do more than that, and that's today's freebie. We're not entering into a contract. So, plug the test equipment. I think we'll run through how this is performing right now. He's got the weirdest serial number on this. 73000001. You have to turn your computer upside down, but it's number 1. That's impressive, isn't it? So we'll plug our test instrument speaker in right now as well. Move the camera back to its more, in fact I'll go to its normal preset, which is there. So plug in his microphone. I've no reason to believe there's anything amiss with that, and certainly not with the type. I don't do coffin mics, but there's no reason to not use it. Somebody emailed me or messaged me and they said, have you got an original mic for a such and such? We've only got 15% of original mics for our own radios. You know, so by the time you buy a scrap chassis, it doesn't come with a mic. And a lot of the radios we buy that do come with a mic, you know, like you buy the odd set on eBay, it comes with one of those really dreadful cheap power mics of the type that, what's this here? An Echo power mic. I mean, come on. We pinched something out of that. What a piece of junk. So, we will need to change those capacitors, but first of all, whilst it is still working with those in, we're going to go through a before and after. And then when the customer says you fixed it worse, I love that phrase, we'll say, oh no, we haven't. Right, picture-in-picture selected. I'm going to we're on channel 20, I've put the test set onto its 3 watt range, and let's see whether we get full scale deflection, which is 3 watts, or whether it pegs the needle. And we're on low power. It pegs the needle. The radio is doing 4.4 watts, and that's got to come down. So now we'll look at deviation. 1, 2, 1, 2, 1, 2. Why are we tuned in? We are not tuned in. We are not tuned in. There is no audio. He's quite right. So deviation, no TX audio. Just as a point, which is the deviation? It's that one there. Just going to put that on there, transmit, and see whether we get a hum on our Capo Panther we're using as a monitor receiver. So as I key up, we can hear that's keyed up. Let's look at receive. So we've got 2779125 channel 20 on the signal generator, and we haven't got the deviation meter even, sound meter even switched on. We have now. So for 12 dB synad, this radio is doing, looks pretty lousy to me. I'll show you the attenuator controls so you can see that's about on the 12. We'll go over to the attenuator controls. We've got that on 3 and that on 0.25. So it's 2.5 microvolts for 12 dB synad. I'd expect this really to be under 0.7. They're not as sensitive as Cybernet sets, unless I've seen only ones which aren't. There you go. People say, well, better for bleed over. I'm not surprised if they are deafer. So, one of the things I don't like about this chassis is you can't adjust the frequency, which I do really find frustrating. What we're going to start with doing is changing those capacitors which we know are dodgy. So I'll take that microphone back out, we'll switch picture in picture off. We've got our initial readings. So I'm going to start by doing the 220s. So we've got that one there, and that one there. So let's get rid of those three. What's that? Right, so we've got to a stage where we can't change that capacitor because we haven't got them in stock. So I'm going to have to order, and that means that we won't be able to complete this until those come on Monday, and then we may not be able to fit it in. So it does hang it around probably another week, which is annoying. I did have some of those in stock, but they're about £3.50 each. I don't keep that many in stock, I only keep about 4 at a time in. I know my friend Stuart had a couple of them, and we must have used the other 2. So we'll switch this on. And one of the things I did notice is that the on and off switch on this doesn't switch the power supply on. This power supply runs 24/7 whilst ever it's plugged in. I don't like that arrangement. I do prefer it when the actual power goes up to the switch, and it doesn't. All that does is switch on the 12 volts, shall we call it, and let's see what that voltage is. So I've changed the capacitor there, which is the 220 microfarad one, and that's the one that fails. So switch on, assuming that to be chassis. So if we go to the on and off switch, 11. Are you sure? Okay, so this must run at 12 volts and not 13.8. Alright, don't go in that hole then, go in that one. Oh, that's full whack, is it? 11.5. You see, that might come up when I change that capacitor. Anyway, it's not going to. I don't think if it's doing more than 4 watts already, it's not going to affect it. So I think what we'll just do is we'll just check. Is this one that has a battery that works in it? It is. We'll just check some of these capacitors I've taken out. So I've taken 2 470 microfarads out of the amplifier. Wow. Sorry, that's 220, and it's 237, so it's slightly starting to rise, which isn't ideal. This one's 470. $511. So when they go high, it starts to sometimes show the failing. Let's try the next one. 490. That's in the works somewhere. And then we've got the other 220s. 248. Right, folks. So that is reading virtually short circuit. So that must have been that one, because if it was that one, then there would have been no display. And that could be all that's wrong with the transmitted audio. But I say, if you don't do them today, they'll fail tomorrow. And we learnt this lesson the hard way by getting a set back days later, which we'd repaired the set, but I'd only changed one of those, not realising at that time that they were all that type of capacitor are now beyond their date at 38 years old. So experience has shown us to change those two, that one, and then in the power supply, especially that 220 microfarad one, but we will be changing that. So if I can remember where we put his microphone, which is neatly on the floor, we'll go through the transmitter. 1, 2, 1, 2. Have we got audio, or is it still a problem? Testing 1, 2, 1, 2, 1, 2. We don't have audio. Without getting the manual out, I can't remember whether that one's transmit or receive. We'll soon find out. So we'll just put the picture-in-picture back on. Must be transmit because it's not affecting receive. Right, here goes. It's a matter of getting the peak. Spot on. Spot on. Unlike Cybernet, they don't seem to have you on to balance these. That's now in the way. Oh, so that one is a wrong choke that just pushed down the inductor. That's handy, isn't it? Not. What I'm doing is not pushing on it, and fingers crossed, but it's so mashed up. So we've got this set for parts. I know we've had coils out of these before, the cores out of those. Because it's been sealed, it's not wanting to move. Hey! So it's not the core that's at fault, it's actually the coil. It's been messed about with so much that the threads have failed. So it wasn't the coil, it wasn't the core, it's the coil. Well, what we'll do, I'm sure there's a scrap Uniden here. Yes, there is. And look, it's still got that coil in it. Again, this is how we've bought a set, and you know, you just get what you can off it. I usually pay a couple of quid for these, and you know, I would charge £1 for each part we take off, so you know, you hope that you're going to get your money back even when there's such a lot missing. So we'll unsolder that. So that's recovered that. So hopefully we can pop this one out as well. Switch back on and go into transmit. And there we have 4 watts. Let's see how on frequency this is. There's nothing I can do about it if it isn't. Should be 27,79125. It's getting to the limit, isn't it? So while we're still on transmit, and when we do that capacitor, we'll recheck that transmit's doing the right power. We may as well do the RF meter on the front, seeing as the meter is working. And that wants to be to the 4, which it now is. Low power wants to be 400 milliwatts. Helps if I press the right button. And low power is in fact 800 milliwatts. think it's that one. So, you know, I'm not showing you the right one. 400 milliwatts is there. So that's that done. So that does now bring us on to deviation. So let's see what's going on. Can be a dirty preset, as simple as that. That's the service hole on the floor. One, two, 1, 2. 1, 2, but it isn't. It's a radio with mic gain. I'll tell you what we're going to do. We're going to switch it to public address and see whether we've got audio in public address mode. So that's now plugged into there. Select PA. Testing 1, 2. Absolutely nothing. So we know it's nothing to do with the transmitter. And what we need to do is to restore it to public address. Supposing it's a duff mic, I mean, there's always that possibility, isn't there? So I think we've got a Uniden mic, which I prepared for a job the other day. Could be this one. One, two, 1, 2. But it isn't that. So it's time to get the circuit diagram out. And this is where we have to use something near enough. So we'll use the realistic 2000. See if the troubleshooting hints help. Is it coffee time? Yeah, I reckon it must be. Get to the hard bit and go for a coffee break. IC4 is the microphone amplifier. So you could have a situation where somebody's miswired a microphone, especially a power microphone, and then the input from the microphone looks like it goes into pin 3, and they could have blown up the IC there. I mean, that's a very feasible thing to happen. So if we prodded pin 3 of IC4 IC4's there. So we'll stay in public address mode. So pin 3, we're getting a click. That then comes out, I think it says usual problem because it's a photocopy. I think it's pin 7. Tell you what, we'll prod out all of these. Now if it comes out of pin 7, which it looks like it does, then why you would expect me to be able to get a click from there, which I'm not doing. So we're getting, that's mic gain. It's just come on its own. Just come on its own. You know what that tells me? It's a duff capacitor. So have we got an electrolytic? Well, yes we have. And that electrolytic is between the two. There seems to be one there and one there. So there's two electrolytics in this microphone amplifier. You've got another one there, but that I don't think that would affect it. But the way it's coupled between those two definitely would affect it. And then there's one there. I think it's that one. So now when we prod pin 7, so again it's a scan of a photocopy, so it's not ideal. We need to be changing, we definitely need to be changing that one. No, that one. Looks like capacitor 75. And there's capacitor 75 on the radio. I could have done without it waking up though. Now it looks to me like it's 25 microfarads on there, but it isn't, it's 4.7, so is that not right? It definitely says 75. Oh, it says 4.725 volts. Whoa, there you are. In circuit. So it's still reading duff even though it was working that little bit. So I'll just go back to stores and we'll go and get a replacement 4.7 microfarad capacitor. So we'll just out of interest test the new Nikon one. These are all Nikon components that have gone in today. All 0.8. Testing 1 2, testing 1 2. Testing 1 2, testing 1 2. Testing 1 2. Why am we getting a crackle? Is it the mic? Is it a dirty switch on the mic? So now we'll substitute our mic for the customer's mic, because I only made this one up yesterday. Testing 1 2, testing 1 2. Why is there a delay? Anyway, that's how it is. So we haven't got the crackle on this one. Perhaps the switch is dirty on the other mic. So we'll go out of PA mode. And now we hopefully have transmit. I can see it on the deviation meter now. Wallow. That's it. So listening now on the monitor receiver. Testing 1 2, testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. 1 2 1 2 1 2 1 2. Good. So just to be clear with the theory behind this, you've got the microphone preamp in two sections. Yes, there's electrolytic capacitors which are coupling it, and they seem to be fine. But this one, you know what, it might be prudent to change both of those for what they cost. But this one couples it to the varactor diode, which does the deviation, and of course disappears off to do the public address. So that goes to the mic gain control. So, yeah, I think it will be prudent under the circumstances to do both the others, but we'll do that later. It's capacitor 86, is it? And 97. Could be 96 and 97. So where are those on the radio? 90. That's 96. '96 and 98. I'll see if I can find a better circuit of a better circuit of the diagram, a better copy of the circuit, and just see if I can read perhaps on the computer screen, or perhaps with a different model. We've got the 2000. We've got the realistic lower model we have on the back page. Let's see if that's any better. No. 97, it looks like 96. That's 96. Anyway, I think we'll definitely change 96. Anyway, I'll get on with doing the radio. See whether we can do something about the receive. So let's look at that cyanide meter. Tell you what, we'll look at the oscilloscope first and put an S9 on the signal generator, which is 100 microvolts. Give it enough volume so we can actually see a nice waveform. I've said a million times, it's only connected across the extension speaker socket. It's just a, well, it's a 10 meg oscilloscope, but it could easily be a 2 meg oscilloscope. It doesn't matter. So the detector coil, we'll just guess it's that one, and that is peak. There was no problem in where that previously was. So now we'll go over to the cyanide meter, just see whether we can get a bit more out of this receiver, because it was pretty atrocious. We've gained a bit there. So I'm just going to go through these again, because it can be interactive. We'll put a bit more signal on for these others. Wow, that's miles out. I've lost my tool, it's down there. Let's see where the cyanide is now. Yeah, we're now at 0.69. Show you the attenuator controls to prove it. But 0.1, just under 7. So before we were, was it 2.5? It was there. And that's now showing as S1. Let's just do the S meter while we're here. That should be S9, and it's showing plus 30. So signal meter control is that one. So that's now on the 9. And that's 0.3 of a microvolt we can hear. Hear it down to about 0.2. Let's see where the squelch is. So we'll turn the squelch to full. Then we'll advance the signal generator until we get to 100 microvolts, at which point the radio should come in. So that's 30 microvolts, that's 100 microvolts. Radio hasn't come in. Radio comes in at 30 millivolts, which is far too strong. So we need to back that squelch off. So we'll have that so it's just open. That's exactly where I want it to be. So now we'll turn the signal generator to standby. It's parked at 0.3 of a microvolt. Turn the squelch down and set it to threshold, and switch the signal generator back on. Coming in at 1.3 microvolts and leaving at 1.1 microvolts. So I like them a bit more sensitive than that, but that is how it is. So that has improved it dramatically. Now if this drops frequency any further, he's going to have the crystal replaced. I'm going to have to check with the government specification, because it's on that borderline in my mind as to what's on frequency and what isn't. So we'll just check that, I'll do the maths and we'll come back with a figure. I'm going to take that coffee break and do that maths at the same time. And wow, that's an improvement. Okay, roll on a bit longer, and what I did was to go on the computer and look at the circuit diagram. Not the same one I had there, but one I found on the internet at some point. So what I've done is to cut and paste that section and print it out a bit bigger. So the first capacitor we changed, which was the one which appeared to be causing the problem, was there. And then when we look carefully, there's an electrolytic there, capacitor 91, which is 1 microfarad, capacitor 96, and I think it's capacitor 95. So we've changed them all. So now we've got 4 new capacitors in that microphone preamplifier section. So if you remember, when we tested that one, which was certainly brought back operation, but then it brought it back on its own, didn't it? Which is always worrying. What you don't want is to send radios out and then they come back days later. Yeah. So you see, that one I've taken out is dodgy too. I think this has had a power mic up it wired wrongly, because a lot of these are 10 volt rated, so if you put 12 volts up it, it would destroy the capacitors. So we've changed them. Now, one of the things which we still seem to have when I thought I'd fixed it was slow to go into any audio. Testing 1 2, testing 1 2, testing 1 2. We've still got a crackle though. Testing 1 2. Do you know what? If I waggle the mic socket, it's there. So what I'm going to do is twofold. With the fiberglass brush, we'll clean the pins. And then we'll just open them up a bit, because it's possible they have closed slightly over the years. Testing 1 2, testing 1 2. Testing 1 2, testing 1 2. Testing 1 2, every time, no crackle. Which is another little thing to watch. That capacitor's on order, so I think we're done. I think we've set everything there is to set. Oh yeah, frequency error. So, now the test set's been warmed up for a few hours. Let's just see where we are with the frequency error. It's 2779066. Now, I like them to be pretty close to the 79125 it should be. But as I said before, the reference crystal, they drop with age. There's no adjustment on these radios. And you get what you're given. So, he's still in spec. And I've checked the spec. I had a look at MPT 1320. It says we're allowed, before the government inspectors come and beat you up, we're allowed a 1.5 kilohertz error. But in reality, an acceptable limit is 1 kilohertz before people start sounding off frequency. So the fact we've got, it should be 2779125, so that means that in reality, anything from 79025 to 79225 is going to be acceptable before it sounds wrong, and the government is 50 beyond that as well. So the fact that this is 2779066 is well away from the 025 where it would start to sound dodgy. And we're going to do a scratchy corners test on this in a few days' time. Obviously, I'm waiting for that part. That's not going to affect anything at all. It's just a reliability thing. So I'm happy that we're not only within spec, but we're within what sounds right as well. But it is further away than I would normally like. So that's it. So in conclusion, we changed the 3 220 microfarads capacitors there and there, which are troublesome now. Changed the 2 470 microfarad capacitors, which become troublesome in the amplifier. We had no transmitted audio, and it was down to that capacitor. I changed the others as a precaution, and they've all read a bit dodgy, and that is how it goes. I'm not an advocate of changing every capacitor in sight. We've done experiments on that, and I've had customers ask me to do that. But it's time consuming, it's expensive for them in time. So that, I think, is where we plug the radio into the aerial. We are going to have to take it off this bench, because I'm not going to get that part till Monday, and we will not be able to not do any electronics work on this bench that far into the future. Let's plug. Oh, I'll tell you what we haven't done. So we haven't written down where we've got that received to. I can find my notes. There we are. So transmit was doing 4.4 watts, which was over the top. It's now doing 4.2 watts, and that's as a warm set. Sorry, I'll say that again. It's a cold set, and so that drops off pretty rapidly within seconds. We're allowed a 10% measuring error, so that's well within. Put that down as 4 watts. No TX audio. Wallow, 1 to Wallow. Where are we? Let's have a look. 1, 2. Yeah, 2.2 to 2.5. Which is correct. And we got down this sensitivity issue, and let's have a look where we are. I'll put that up on there. I'll say that's 12. So we'll now turn straight over to the Attenuator Controls, so you can see 1 and 5.8. So it's now 0.58 microvolts for 12 dB synad. So that's brought it from 2.5 microvolts to 0.5, and that's really with that tuning. So looking back at his letter, we were able to unjam that meter. Yep, still working. The transmitter audio, so it's got receive sounds scratchy, so that's been issued, dealt with. No transmitter audio, capacitor, S meter stuck, and although we wouldn't do that and we wouldn't charge for doing that because I don't want to enter into a contract, I've nevertheless managed to unstick it. And I said before, it's like going take your car for service and say the speedometer's stuck. Well, it's not really their job, it's a part. So we are done, and we'll put that on the air just like I was about to. And we're just about noon, so we're alright to go and tune that organ, which I'm not looking forward to doing, which we did last week unsatisfactorily. So night in a Roger. There we go. So that's it. We'll do an on-the-air test when that part comes. So that concludes the service and repair to the customer's Uniden 300 base station. And very nice it is too. Thank you for watching.